Okay, here's just a little help for you when calculating the surface area of a cylinder. That seems really intimidating, and when you see those mathematical shapes up there, sometimes they can be a little scary. But guess what? They are not as bad as you think, especially if you start to think in everyday objects. I suspect that every single one of you have come across a soup can at some point in time in your life. And if you think about it, that is a cylinder. And when you're doing surface area, you want to count every single exposed surface. So a soup can, you have a top, you have a bottom, and you have the label, or what goes around the side. When calculating surface area, you just need to calculate the area of each of the surfaces of that three-dimensional object and then add them together. We have 3 surfaces, so let's calculate the area of those 3 surfaces. First of all, we have the top. So the formula for the area of a circle is simply area is equal to pi r squared. And remember, pi is that magic mathematical constant. So let's plug in what we know and then chug out the answer. So do we know what pi is? Yes, we do. It is 3.14. Do we know what the radius is? Well, let's check and see. What does our diagram say? If we look back at the information with the problem, what did it say? It said, let me get my pen back, that the radius was 3.75. So let's plug in what we know. 3.75 centimeters, and that is going to be squared because remember it's radius squared. So what do we need to chug out now? Well, let's do some simplifying. Let's leave the 3.14 for a while. 3.75 centimeters squared. That's the same thing as 3.75 times 3.75 because it's squared. And then our units are centimeters squared. Simplifying a little bit more, we'll multiply each of those things together. Grabbing our calculator, 3.14 times 3.75 times 3.75 equals, excuse me, 44.156. And don't forget our units. We don't want to have naked numbers. Now, I know that my handwriting is not the best, so here is a slide right here with it all typed out nice and neat. So the bottom is exactly the same as the top. Lucky for us. So we already know pi is 3.14. We know that the radius is 3.75 centimeters, and we are going to square that. We should be able to do this without any issues or problems now. 14.0625, sorry, centimeters. Running out of room. Simplify that even further, and we end up, and this should not be a shocker, for 44.15625. My numbers are moving. And don't leave naked numbers. It needs our centimeters squared. So 44.15625 centimeters squared. And again, I know I have sloppy handwriting. So here it is done nice and neat. Now the tricky part is when we start to look at the label. If we were to take the label off of the soup can, what would it be? It's a rectangle. We're used to looking at cylinders and thinking circles. But if we take that side, open it up, and lay it out, we have a rectangle. Get my pen back. I lose my pen every time I go to a different slide. It's a rectangle. What's the formula for calculating the area of a rectangle? Easy. It's width times height. We should not be intimidated or scared by that. Area is equal to width times height. What is the height? If we go back to our very first slide, remember story problems, they always hide the information. The label, it's 11 centimeters. back to where we need it, to where we're working. What was the height? 11 centimeters. Get my pen back. There we go. Our height is 11 centimeters. Tricky, what's the width though? Well, if you look at it, where does the width come from? I take this picture right here so that you can see, strange but true, the width is going all the way around the can. If we take the label off and lay it out, the width is the same thing as going around the bottom or the top, which is a circle. The width is the same thing as the circumference. So how do we calculate circumference? Let's get my pen back. Circumference. That is equal to pi times the diameter. And if you don't have these formulas memorized, that's okay. It's okay to refer back and make sure that you have the formula correct. So, circumference, we don't know. That's what we want to know. We know what pi is. Let's plug it in. What's the diameter? They didn't give us the diameter in that problem, did they? Let's go back to the original. They told us what the radius was. Well, that doesn't mean we have to be permanently stuck. If we know the radius, we can calculate the diameter because the radius is the same. 2 times the radius is the same thing as the diameter. So we could put 2r right in there. And now we can chug it out because we know that the radius was 3.75. Now we chug that all out. We get the circumference is equal to 3.14 times 2 times 3.75, and we get 23.55. Now we have the width and we have the height. We can plug that into our area formula right here. Instead of writing width, I'm going to write 23.55 centimeters. And instead of writing height, I'm going to write 11 centimeters. Times that together, and we get 200. Obviously, I did not leave enough room. 259.05 centimeters squared. Why centimeters squared? Because I'm multiplying centimeters by centimeters. And again, I know I have messy handwriting, but I think there's some benefit to watching the steps as I work through this. Now, we've got the area for the 3 components that make up the surfaces of a cylinder. All we need to do is add each of those together. 44.15625 for the top, 44.15625 for the bottom, plus 259.05 for the side or the label. That comes up to 347.3625 centimeters squared. Now, here's a problem for you to try on your own. I ask you to please pause it because I've got the answer on the next slide. So give yourself a pause while you work it, and then you can check your work on the flip side. And here is something a little bit funny to make you smile as you go. Okay, this won't work with cylinders, but this does work for the surface area of a cylinder, but this does work for the volume of a cylinder. All you have to do is remember pizza.